Hi, and welcome to Section 4, A Place for Everything. During Section 3, we added functionality for viewing libraries and deleting unwanted books from our collection. At the same time, we started utilizing third-party packages to write cleaner templates and route handlers. In Section 4, we're going to focus on sorting and filtering our book collection to help the user fulfill our initial goal of putting together a bookshelf. We'll start this section by integrating the third-party package go-gorp into our application for cleaner database access. Then we'll introduce the functionality to sort our book collection. Finally, we'll add the option to filter our library by fiction or nonfiction. In this video, we'll take advantage of the third-party package known as go-gorp to make database calls a little easier. We'll use go-gorp to abstract deleting and inserting rows into the database and to bind Go objects to database objects. To start, we'll need to download the latest stable go-gorp files. Then, we'll need to set up the database mapping so that go-gorp knows how to communicate with the database. In the end, we'll rewrite our database calls to take advantage of these mappings. Let's get started. go-gorp is a humble package which provides a layer of abstraction between our code and the standard SQL library. Using go-gorp allows us to make database calls through an API instead of through raw SQL statements. At the time of this recording, go-gorp is making some major changes on the main branch, which could introduce breaking changes to the API. With that in mind, we'll use the go-pkg.in service to install version 1. Installing Go packages with a GitHub URL can pull unstable packages into our codebase, and go-pkg.in gives us an easy way to find stable versions of Go packages, in this case, go-gorp version 1. At the command line, run go-git go-pkg.in/gorp.v1. This could take a moment based on your computer hardware and network speeds. Let's open up our main.go file and update our import list with go-pkg.in/gorp.v1. The first thing we need to do to utilize go-gorp is to define a database mapping. Let's create a new method called initdb. We'll start this function with the original call to sql.open from the main function. In the main function, we'll call initdb. Let's define a new variable alongside the pointer to the database called dbmap, which will be a pointer to the instance of gorp.dbmap. We'll initialize gorp.dbmap inside initdb with two properties. The first property is the pointer to our db object. The second property is the SQL dialect of our database. In this case, we're using SQLite. Currently, our database has one table called books. We'll use the addTableWithName method on dbmap to let go-gorp know to expect a table which matches our book object called books. We'll call setKeys to tell go-gorp the primary key of the book table. We'll set the first argument to true, which means that our key is auto-incrementing. The second value is the name of our primary key column, which in this case is pk. Now we can tell go-gorp to create the table if it doesn't already exist in our database, using the createTablesIfNotExist method. This is especially useful during development if you ever need to recreate your database from scratch or add new tables without using the SQLite console. We also need to tell go-gorp how to coerce a book object into a database row. We can do this by adding dbstruct tags to the book struct just like we did for XML and JSON. For each of pk, title, author, and classification, we just need to use their lowercase counterparts. You may remember we also have a column for ID, which we should add now so that go-gorp knows the full definition of our object. go-gorp will also want to see the primary key set to type int64 instead of just int. In doing this, we'll be able to add the maximum number of rows to our table without running out of primary keys. Finally, it's time to replace our raw SQL calls in favor of the new dbmap object. Starting in the root route, we'll need to update this call to query to use dbmap.select. Select will take in an object to populate as its first argument and a SQL statement as its second argument. We want to populate p.books, and we'll use the ampersand to reference that object as a pointer. We'll use the SQL statement select star from books to fetch all books from the library. Select will return an error, which we should handle in our usual way with a conditional and a call to http.error. We can remove all this code dealing with rows as that's no longer needed. Next, we can update inserting books into the database in the add route. We can start by deleting all this code except for the book initialization. We'll update the value of pk to be -1, since go-gorp will populate this with a new value once it has been inserted. In this case, we just need to call insert on the dbmap object with a pointer to the book object we just created. Insert will return an error if there is a problem, so we'll be sure to check that error and handle it appropriately with a call to http.error given a status internal server error. Finally, let's handle the delete route with go-gorp. Doing this delete will require that we create a book object to pass into the dbmap with a given primary key. To parse the primary key as an int64, we'll need to use a standard library package called strconv. Let's add strconv to our import list. Now we can use the parseInt method on strconv to parse the string value contained in the pkroute variable we were using previously. ParseInt also takes in the base and bit size. In our case, we want to use a base 10 integer that is 64 bits. In place of the call to exec on db, we'll call dbmap.delete. Delete will take in a book pointer which we'll create with all empty values except for the pk we parsed with strconv. Delete also returns an error, so we can leave this conditional as is. And with that, we've fully integrated go-gorp into our code. Let's restart the web server to test our application. Open your web browser to localhost 8080 and try to use all the functionality to make sure everything still works. We can see that getting all the books still works on the view page. We can see that adding a new book works from the search page, and checking that it exists on the view page afterwards. We can also check our delete on the view page by clicking the delete button. In this video, we used go-gorp to streamline our database calls.